Hey, what's up, AP Stats? Thought you were going to get rid of me today. Sorry, I'm here. I am here. I am definitely here. I can watch everything. In fact, there's a camera right up there. I see each of you very creepily see you. Hey, real quick, I wanted to do something. Charles, I know that you're going to miss this today, so this is actually a shout out to you. You ready? Are you ready? Here we go. Here we go. Here we go. Here we go. Let's go. Let's go. Wow. Let's go, Charles. Here we go. That's right, Charles. That was for you. I hope you enjoyed that. Hey, also, what the heck? We're gonna do something else. Today we're gonna talk about cookies, and so I just realized this new term. I'm a basketball coach. I didn't realize, like, when you get a good steal in basketball, it's like cookies. Like, people are like, cookies. I didn't know that. I thought that people just like cookies for some strange, odd reason. And so because of that, I'm going to show you a clip of one of the best steals in NBA history. I thought this was just really cool. Check this out. And yeah, it should be kind of cool. Check it out.
And a nail biter.
Oh, cookies. Get you some. Oh, come on. Yeah, that's cookies right there. I tell you what, right there. I got cookies today. I'm going to get cookies today. Let's get cookies today in this lesson. Our cookies today. Let's do this thing. All right, here we go. We're going to go real quick, real fast as you go to – actually, I don't want that. All right. Yes. Okay. So back in the back, you're going to see, I'm going to actually show this real quick because we can. Again, you thought you thought you were getting rid of me? Not today. Not today. All right. So right here, right there, there's cookies right back there. I need you to do me a favor real quick to get started. Hopefully you've started this podcast already. Those cookies, you need to get one of each. Please don't eat more than that because there's 2 periods, so just be sure. One of each of those. Don't eat them right away. There's also notes right there. You're going to need those note sheet, and there's a note sheet right there. Okay, so as you go right over in that area, get cookies, one of each. Go to your desk with the note sheet, and let's get started. You're going to need a good team event, team activity. So let's make sure that we're getting after it. Make sure we're rolling. Also, hey, do this for me if you feel compelled. Hey, give me a maybe not a video of you going crazy, but if you want a picture of you and some people working, do that. Throw them out there. I'd love to, I don't know, just see how everything's going. Hope everything's going well. And yeah. Hope we're rocking. Real quick, make sure your phones are away, unless you're taking the picture, that is. Make sure you get that note in the back and then the cookies. We're good to go. Make sure we're continuing to work on the project. Make sure also, I forgot to put this out there, make sure the quiz is due Monday. And then also keep cleaning up data. That's the 2 things I would say continue to work on. All right. All right, let's look at this. We are not using Target cookies. We're using Kroger. A little bit different. I thought I was going to use Target, but I ended up using Kroger. So anytime you see anything that's different, like Meijer or anything like that, you could always replace this with the word. Now we can just replace it now. This is going to be not Meijer. You're going to actually put in Kroger here on this side, okay? All right, so Kroger. It's a little high for me, but I got it, and there we are. Okay, so here's what I need you to do as you go through these cookies. You are not going to dissect them like this. I don't want you to do that. It's not necessary. You're just going to look at the top and on the bottom, and you're going to count the amount of chocolate chips on the top and on the underside of the bottom. You're going to do that for both the Chips Ahoy brand and the Kroger brand, okay? So I'm just going to use my data, for instance. I've got the number in Chips Ahoy cookies. Let's say I get 10 chocolate chips, but yet in Kroger, let's say I've got 8, okay? All right, so what I'm going to do is I'm going to go ahead and put 10 over underneath the Chips Ahoy area in the back of the room. You'll see all of my unique sayings right underneath there. You'll put that in the Chips Ahoy. And then you're going to put 8 underneath the Kroger brand and go from there, okay? Now, once I do that, it's important that you understand that you could find what your mean, and I'll have this pulled up. So back there, right over in that area right there, you're going to put the Kroger and the Chips Ahoy. When you then find the mean and standard deviation, again, of the sample, you're going to go ahead and pull up your calculator and go to one variable statistics. Make sure you put in your L1 data, find your standard deviation, and I'll just make sure I show this real quick. Standard deviation, hold up, no. Y'all seen a picture in a picture? Oh my word, that was, I don't know what just happened. Oh man. All right, so there we go. All right, there, okay. So what you'll do is for your specific class here, you're gonna go to your stat, go to calc, one variable statistics, and then you'll put in your L1, okay? Today we're gonna be living in our test, which is a 2-sample t-test. Remember, we've been living in 2 proportion. We're gonna do 2-sample t-tests where I have the mean, I've got the standard deviation, sample size, and obviously we're doing the difference of the 2 sample t-tests, so the difference of 2 samples that are there. Okay, so go ahead, pause the video for me for just a second. Go ahead and plug those in, and we'll proceed accordingly. Okay, so plug them in, and we'll go from there. All right, back with you. Hopefully it's unpaused at this time. I'm going to use just an example of this. Hopefully this will help you. X bar 1 we could say was 8. This could be 1.2. I mean, it could be anything, right? This could be like 6, and that's really a low, but oh well, we'll just roll with it. We'll say it's 0.7, and then we'll do the difference, okay? So you're going to plug in the difference, just like before when we talk about a confidence interval. If I were to draw this, and we're trying to talk through the confidence interval of, does it say here? It doesn't say. Oh, it's going to get there, number 5. But when we get to a confidence interval, let's say we're at 95% confidence, this would be our middle. We'll still have our lower bound. We'll still have our upper. And then our mean would be the difference. Whatever our difference is, we'll put right there in the center. So our difference in this case would be 2 for our sample that's there, and we'll put 2 accordingly, okay? All right, number 3, let's talk through the idea of what this could be, right? So you need to make sure you show this down below, but what I'm going to do is hopefully set the tone for you on how to solve for each of the parts that are here, okay? So in the state part, you need to make sure that you say what the difference is. You need to make sure you identify in context what mu1 minus mu2 is, what you're trying to say, that you're 95% confident that the true mean difference between Chips Ahoy cookies and Kroger is between this and this. And that would be in our state for the parameter that's there. Remember also that we're talking 95% confidence level. And again, that will come on number 5. So that wasn't stated until number 5. Remember with the shape, we have 3 conditions. Number 1, does it say that it's approximately normal, right? Number 2, we go into the idea of the central limit theorem, which ours is actually not, because we don't have 30 people in our class. And then the 3rd would be actually graphing the data, making sure that there's no major outliers or skew on the sample that's there. But it also says here, the population is approximately normal. So we could just say on this that on number 1, that the population is approximately normal. Yeah, and I've already stated it there, okay? All right, try to find the center and spread. Try to pause me real quick. See if you could find the center and spread, and then go from there, okay? All right, you're back with me here. You got mu of x bar 1 minus x bar 2, hopefully. This equals the mu1 minus mu2 as far as my center goes. Remember, we're using our sample to be able to estimate that because we don't know what mu1 minus mu2 is, but we know that that would be our center that's there. Remember our spread traditionally was sigma, and you could actually pause it if you want to try this out. But sigma of x bar was equal to s of x over the square root of n. Do you remember this? Well, now it's a little bit different because now we're going to actually write, and I'll put this here. One cannot simply add standard deviations and torrents. Can't call me out on it anymore, my man. Can't call me out. So we got sigma of x bar 1 minus x bar 2 is equal to the square root of, this is where we go, s of x, s of 1x, or s of x1, I guess, squared over n1 plus x of x, the second one, squared divided by n2, okay? So basically you could just say s of 1 maybe. That'll make it easier. S of 1 squared, s of 2 squared. The only part that's being squared is the standard deviation, not the n1. Only the s of 1 and s of 2 is being squared. So just a heads up there when you plug it in. Go ahead and find your spread really quick and find your center. Your center should come straight from your x bar 1 minus x bar 2 because it's an estimation of what the true mu1 minus mu2 would be on that, okay? All right, number 3. You should get this one. Try to find the conditions. Pause me real quick. See if you can find the conditions from that. Right now, if you're going at different paces amongst the class, then I'm good to go on that, okay? So try to find that out. All right, condition 1. You should have said that it was random because it stated that it was a random sample. It's condition 1. Condition 2. Dos says the 10% that n is less than or equal to 1/10 of all n, and we've got to show this for twice. So we would say that n1, how many ever are in the class, is less than or equal to 1/10 of all Chips Ahoy cookies, and all Kroger cookies would be 1/10 less than or equal to from n2. Okay. Condition 3. Condition 3 states that we are the normal condition. We've already stated that. So I could just say it was stated, or you could just say look at number 3, which it was already stated there. Okay? Cool, cool. All right, now number 5 is where we come into play. We're going to construct this. Remember, we've got the picture on the previous page. We remember that when we use a confidence interval, estimate plus or minus margin of error. Try it out real quick. See if you can figure it out. Go. All right, unpause me here. Once I edit this, put this in, remember this is more the do phase. You can go and do a 2 sample t interval, but remember it's important to at least do this once so that you have an idea of what it could be if it was on a multiple choice. But you could also do this if it was on an FRQ. You could do the 2 sample t interval as long as you show it there, okay? So we've got x bar 1 minus x bar 2 plus or minus should be t star times the square root of s of 1 squared over n1 plus s of 2 squared over n2. And that's how we would plug it in, right? Plug it in just like this. The big thing to remember is the degrees of freedom. This is the formula you'll need to memorize. Just kidding. Actually, I'm just joking. It actually is the degrees of freedom. But we're going to do this. This is hopefully helpful for you. The degrees of freedom is n minus 1. And you say, Coach, what n do I use? Do I use n1 or n2? And I would just tell you that you use the conservative one or whatever one's the lowest. Use the lowest one. Now for us, n1 and n2 are both the same, so that makes it fairly easy. But when you go ahead and do degrees of freedom of n minus 1, let's say we had 13 students, we would find t of 13, right? T of 13. And when you go to table B, make sure that when you go there, we would look and see. Let me actually put this here. Remember, over on the left-hand side, when you go to table B, on the top you have the area that is to the left right? So you have your T graph, you know, this and that. So this up here, as I look at it, is shaded to the left. So if I think of 95%, I'm looking for the one that's 0.025, because here's 95%, because you have 0.025 at either side. So I'm looking for this up here, and then this is the degrees of freedom down here, and then that would get you your T star, wherever it is corresponding to, say go here and here, whatever value it corresponds to within this would be that T star value going forward, okay? All right, number 6, do we have convincing evidence? All right, so I hope you can always go back in this podcast, but there's 3 possibilities. You can remember it's talking about X bar 1 minus X bar 2, which is Chips Ahoy minus Kroger mean, right? So if I get plus plus, that means that Kroger is less than Chips Ahoy. Chips Ahoy would be greater, right? If it's a plus plus, we'd say Chips Ahoy, you have, well, we believe based on our data that Chips Ahoy, you have more chocolate chips, right? So we would say that. Or if it was minus minus, we would say that Kroger has more, right? Not Myers, I apologize. I know I used a lot of different ones, but we're talking Kroger here. And if we went from negative to plus, we have insufficient. We have no difference. We have insufficient evidence to say, and we have no difference, okay? All right, try to do that out, see if you can solve for it. So putting this all together, the question is on your data, when you go there, the question is should I pool together? Like when we did the beforehand, when we did the 2 proportion Z test, we pooled together, did we not? Why? Because the reality is that we had, I'll put this down so I could think through it. And 2, we assumed that the null was true, right? That P1 minus P2 is equal to 0, that there was no difference. And so because of that, we pooled together. The reason why we do not pool, so we do no pool in a 2 sample t-test, is because we know that the standard deviations are going to be different, okay? So because they're not different, we would say no pool. The only time I would want you to pool is if you were at the Holiday Inn, okay? I'm joking. That was a bad joke. Was that a bad joke? Okay, maybe it was. Maybe it was. I apologize. But here's the golden nugget. Check it out. Golden nugget. Get it down. We went through the shape, normal conditions, center, spread. We're at a 2 sample t interval for the difference of mu1 minus mu2. The conditions, make sure you know that. Make sure you know T star. Make sure you know how to go to table B. Another way you could do T star, you could also find T star by doing TCDF, which is your lower. In this case, for our example, it would be here to 0.025, and then the degrees of freedom would follow, so it would be your n minus 1. That would be there. You could find your T star value that way as well, or you could use table B. Either of those 2 would work. Torrance, this one's for you, just so you know. One cannot simply add standard deviations. Look right here. Whoop, there you are. Yeah, I'm kind of hyper today. If you can't notice, it's at the end of a Thursday. On a Thursday. All right, so then we're good. Okay. The only other thing I need you to do really quick is I need you to try to go after the state, plan, do, conclude. All right, so state, plan, do, and conclude on this. Notice a couple things. Brianna, you had some really good thoughts. I think it was you that came by the other day. Just, hey, how do I know that this is an actual like 2 sample t-test? So we know that it says construct and interpret a 95% confidence interval. So we know that we're talking interval here, okay? For the difference, so we're talking 2, right? Because difference would mean 2. In true mean, so mean would be t, right? So that'd be a 2 sample t interval. And that would be for mu1 minus mu2 when we're doing this. So go through the state, plan, do, conclude. The only thing that you really need to know, you got the mean change here. you may need to plug like these values in for L1 and L2 to find what the S of X of 1 and S of 2 would be, which is the standard deviation. You'll need to know that. So just kind of as you're looking through that, go through the state plan, do conclude. Pause me. And all right, once you're done pausing me, if you could go ahead and turn this in on campus. I should have something that is up there. Just put it on there for today's assignment, and it'll be a quick homework grade, and we'll go from there. Here's the answer to the check your understanding right here. Check it out. Yeah, here's the standard deviations just as a heads up. But this is how I would approach this here. Yeah, pretty good. Pretty good. You could also, on the do face, go ahead and use the 2 sample T interval, and that would be appropriate. Just know how to, know the basics of it, how I could find those parts that are there. And other than that, y'all, let's go. Let's go. Right there, Charles, that's for you. Hey, have a fantastic day, and be blessed. Be blessed, y'all. See y'all. Bye. Bye.